Konnichiwa. Welcome to this talk about the future of cloud programming, serverless and event-driven computing with IBM Bluemix OpenWhisk. So first of all, thanks for being here, and thanks for having us here, and thanks for listening to this talk. Within the next couple of minutes, I would like to introduce you into our view of serverless computing in general and OpenWhisk in particular. Today I will talk together with my colleague Markus, so maybe you want to introduce yourself?
Sure. Hi, I'm Markus, software developer on IBM Bluemix and one of the engineers actually building OpenWhisk. So.
Yeah, and I'm Andreas, and I'm the technical product manager responsible for OpenWhisk, working for IBM. So let me first show you what's on the agenda for today. And I will start giving you a very crisp, to-the-point definition of what OpenWhisk actually is and how it compares to the traditional compute models that we have in Bluemix, which is IBM's cloud platform. I will then have a closer look at how our OpenWhisk really works and how it works behind the scenes, and Markus will then introduce you into the architecture and how we have built it internally before we then dive into the usage scenarios where a technology like serverless and in particular OpenWhisk can be used, and then we will have a short look at the programming model, which I will try to illustrate to you using some demos. But before I start, let me say a few words about IBM and how we started all this. So at IBM, we started diving into the field of serverless computing into the year 2015, when OpenWhisk was initially born as a research project at the IBM T.J. Watson Research Center in New York. At the moment, we have built up more development centers where people are working on OpenWhisk. So we have people in Austin, Texas, we have people in New York, we have people in Raleigh, and we have people in Böblingen, Germany, now all working on this technology. And by the way, we are from Germany. I think that demonstrates very well, it conveys a message, and it demonstrates very well that we from IBM regard serverless to be a very important effort. And it demonstrates that these technologies, serverless in general and OpenWhisk in particular, is something we regard to have the potential to become a game changer for the future way of developing cloud-native applications. But what the heck is OpenWhisk? So let me explain that to you in one sentence. So OpenWhisk is an event action platform that allows you to execute code that you as a developer have written in response to an event. So let me give you a simple example. So think of an IoT scenario where IoT devices or sensors are continuously sensing data, and you want to react on what has been sensed. So the little data that has been sensed can be regarded as an event that is then supposed to kick off custom application logic that you as a developer have written in any of the languages that we support. So that is what it actually does, right? So at the moment, OpenWhisk is being offered as a commercial offering running on top of Bluemix. So if you want to try that out, just go to bluemix.net and look for OpenWhisk, and you can start right ahead playing around with that. But it's also being offered as an open source offering, being hosted on GitHub. So of course, since it's open, I would also like to take the opportunity to invite you to have a look at this open source offering on GitHub. Just have a look, provide us with feedback, and even better, think about participating, being part of that open community, and we really encourage you to participate and even to contribute to this to help us accelerating this entire technology. So, by the way, the funny thing is that I cannot understand my own slides anymore. That's the reason why Markus is here, because he has the English version. So if I look here, I don't know what's being written here. And thanks to Endo-san from IBM, who translated all that for me in a language I don't understand. So OpenWhisk propagates a serverless deployment and operation model, which means it hides any infrastructural and operational complexity so that you as a developer can focus on developing value-adding code very quickly. So if I would be the one who has to define a TV slogan, I would do something like, hey guys, provide us with your code and we just execute it for you. It also guarantees an optimal utilization where you do not have to pay for resources just idling around, right? In the past, when you went with virtual machines, for example, these virtual machines were very often just up and running, but there was no code that you have written being executed. So you had to pay for resources idling around. That doesn't sound very smart. It just costs you damn much money. OpenWhisk also scales on a per request basis inherently, which means at any point in time, we guarantee you that you have exactly the resources you need to properly operate your application. OpenWhisk also provides you with a flexible programming model, which means that you as a developer can develop in totally different languages like JavaScript, like Swift, and I'm really talking about Swift on the server side, we will come to that later, Java, and even Python. So there's a kind of polyglot support. You can even execute custom logic by running a container, a Docker container, in response to an event, which means that even if you want to code something in a language that is not natively supported, you can create a Docker container and execute that in response to the event. And we also support some higher level programming constructs, so the little puzzle pieces that you develop can declaratively, that means without touching a lot of code, being interconnected by using stuff that we call chaining and sequencing, which we will have a look at later. But the best thing here is OpenWhisk is an open technology, and it's even being built on open technologies like Docker, Kafka, and Consul. And due to the fact that it's open, it avoids any risk for any kind of vendor lock-in. So in theory, it can run anywhere, not only on IBM infrastructure. You can take the engine and deploy it on your own infrastructure and let it run. That's a big plus, of course. It also provides you with an open ecosystem of event emitters and event consumers that fall into totally different domains, like, for example, data, cognitive, mobile, and that are being provided by many, many different vendors. So you are not bound to IBM technology only. And even better, it provides you with an open interface for event providers, which means that all of you guys can help us accelerating this technology by enabling such services so that they become an event emitter on your own. And of course, it has been implemented in modern technology. So for example, you have implemented this in Scala, mainly for performance reasons. So the question at this point, of course, is how can a serverless technology like OpenWhisk be better than a traditional model? And I would like to explain that along an example. So let's pick the following example. Let's say you want to react because something has changed in a database service. And it could be a database service like Cloudin, for example. So how would you have done that in the past? You probably would write a little application. The application would be able to connect to your database and then check if there was a change in the database. This little application would then run on top of a VM, or it would run as part of a container, or maybe you have implemented it as a Cloud Foundry application. And what you then have to do usually is you have to do some kind of polling, which means you have to periodically ask the application, hey, has there something changed? Hey, has there something changed? Hey, has there something changed? Okay, I'll stop now. But this is, of course, not a smart approach, but it's necessary because there is no, or was no, real event programming model that would have allowed the service itself, in this case the database service, to tell that there was a change. It could not actively communicate that. And of course, this is bad. This is bad from a utilization perspective, because that means that the application very often has to wait for the next request to arrive. For the rest of the time, it's just idling around. But nevertheless, even so it's idling around, the underlying VM is still up and running, and that costs you a hell of money, of course. And it's also bad from a scalability perspective, because if you went with a VM, you are, from a scalability perspective, bound to what you have ordered. But what if load increases? Then you have to answer the question, how can I scale and how fast can I scale? So you need to answer the question, well, how do I have to set up very complex auto-scaling rules? But this is not what you are interested in as a developer. You don't want to worry about these low-level details and all that scaling stuff. You just want to write your code to implement your business logic and let others do the business of operating a platform. You also need to worry, if you go the old way, about resiliency. So, for example, if you want to achieve high availability, you need to have at least 2 processes, and 2 processes means redundancy, and redundancy costs you money. You probably also want to have deployment in multi-regions. That costs money as well. And you need to keep all that stuff running continuously and healthy, and that's very expensive. I guess you don't want to spend all that money, right? And OpenWhisk helps you to overcome these problems. So we have the little event that we here call a trigger. The trigger is exactly what is being emitted by OpenWhisk, by something like Cloudant. So what happens is the trigger arrives at the OpenWhisk engine, and from the OpenWhisk engine we determine the right action to be executed. And the action is the little thing that contains the piece of code that you want to execute in reaction to the trigger. So, and here's where the magic begins. We take that little action, we deploy it very, very quickly, rerun it, and we return the result. And now we free up the resources again, which means there is never ever idling stuff around that you don't need, which means we come to a 100% utilization. From a scalability perspective, that's cool as well, because if load increases, we can parallelize the deployment of these little actions very quickly so that you always have the right amount of actions that you need to handle the load is coming in. If load is going down, we just get rid of the actions we don't need anymore. So this is really cool. And of course, you don't have to worry about the things that I mentioned just before, like resiliency. This is just our business now. So one question that remains is OpenWhisk actually meant to replace the entire world of technology that we have in Bluemix? Of course not. So OpenWhisk will not replace virtual machines and all the other stuff that we have in IBM's cloud platform portfolio. This is not the idea. All these things will remain to coexist. And they all have their pros and cons. So let me give you a short example. If you want to have the full control over the entire technology stack, if you want to have full flexibility, if you want to be able to pick the CPU, the memory, the operating system, for whatever reason, you can still do that. That's flexible. It's very flexible. But of course, the price for flexibility is complexity, so it makes you a little bit harder to get started quickly. If you don't need that flexibility, you move from the right to the left, where it gets easier and easier, and at the end you end up with OpenWhisk, where you have less flexibility but also less complexity, and where you can start developing event-driven applications very, very quickly. So how does it work behind the scenes? The events that are supposed to kick off actions that contain the application logic that you want to execute, they are emitted by event providers. Event providers might be services that run on Bluemix, or it might be services running outside of Bluemix. If there is a service that has not yet been enabled for OpenWhisk, so it is not yet emitting event, you can do that. That's just what I mentioned, right? We give you the tools to enable these services and donate it back to the community so that this service becomes an event emitter. That's very, very cool. And then the event arrives at the OpenWhisk engine, and there we have something that we call a rule. And the rule defines, if this event is coming in, please execute this action that has been developed in this and that language and just execute it. Of course, you can also invoke an action in a more direct fashion. So you can also do an API call, like a REST API call. So a typical example could be you have a web application or mobile application supposed to display a list of customers. So what you could do is you write a little mobile application. There's a button. You click the button. As soon as the button is clicked, an REST API call is being made. The REST API call arrives at the OpenWhisk engine. The right action is being executed. The action contains some code to go against the database. We fetch the right subset of customers, and we return the result. Very easy thing that you can do. And by the way, if it's a mobile application, you can implement that little action doing exactly the stuff that I've mentioned in Swift, which lowers the barrier for a mobile application developer because he can continue coding in the language he already knows. Very cool, very neat. Yeah, and with this being said, I hand over to Markus, who will now explain you how we have built OpenWhisk internally.
Right. So we heard quite a bit about how we are invoking actions, how we are reacting to events, and all this kinds of stuff. But I have developers and engineers sitting in front of me, so I cannot fool you. There's something is got to do all that work, right? So I will explain quickly how such an action invocation flows through the OpenWhisk system and does all the magic. As you know, there's no free lunch, so we gotta do the work at some point. So let's have a look. Suppose you already created an action, let's call it my action. And let's suppose you want to invoke that action due to any event. The first thing you do is, well, you need an interface to talk to the OpenWhisk system. And Olivier of AWS talked before about microservices. And OpenWhisk essentially is just another microservice. So what we do is we have an HTTP-based API, a RESTful API, and you just call that. Every client that we have, be it the CLI or the UI or whatever, is eventually talking through that HTTP API. So the first thing that you'll see in OpenWhisk is an Nginx, which is, well, an open HTTP proxy, not much magic to it. We can basically just go over it because it doesn't do much for us. It just proxies the HTTP request to the first component that we developed ourselves, which is the controller. And by the way, OpenWhisk, as Andreas already said, is an open source project. Being an open source project means we also stand off the shoulder of giants. So we build on a lot of other open source technologies to not reinvent the wheel again and again and again. We just focus on what we want to do. And I've color-coded this architecture chart a bit. So the green boxes are open source projects that we use, and the darkish blue boxes are things that we developed ourselves. So the controller is mainly, well, the controller. It implements the REST API. It's your interface to talk to OpenWhisk. And what do you need to do first? Well, the HTTP request comes in. We need to do authentication, authorization, all that kinds of stuff to know who you are and what you are trying to do, and ultimately to know who we sent the bill to. So we need to check, are you in our system? Well, we look in our database, which is, in our case, a CouchDB instance, another open source project. So let's assume, okay, everything is fine. You are allowed to do what you want to do. You are in our system. Now we basically get the action code out of the database. Again, CouchDB instance, just get the action code. And we are set, right? I know what you want to invoke. I know who you are. I know whom to bill, which credit card to get the money from. So I can execute the code, right? Well, yeah. So first of all, I need to know where are my executors. So the executors in OpenWhisk are called invokers. You invoke an action. The component that does so is the invoker. So we ask Consul, a service discovery thing, the service discovery agent, to tell us, okay, how many invokers are there in the system. And I will talk about the invoker more in a minute. So now the controller knows where to go. It decides, okay, I want to execute the action on invoker 1. And it does so by putting a message into a message bus, which is called Kafka, another open source project, another green box on the architecture chart. And yeah, Kafka is used to do two things, basically. One, resiliency. If the system goes down while your request is in flight, it will be lost, which is bad. So we put the message into Kafka where it will be preserved, even if the system crashes. And second, it's used for buffering between the controller and the invoker. But let's not get the tension too high. Let's talk about the heart of OpenWhisk, which is basically the invoker. Right? That's where the magic happens. So we see another darkish blue box. So we developed this thing ourselves. By the way, all the darkish blue boxes are Scala-based components. Yay, Scala. And what you see as well is the little Docker sign below the invoker. So I will go into a bit more detail on that in a minute as well. Let's say for the second, the request comes to the invoker. What we do is we spin up a container, we run your code, we get rid of the container. As Andreas said before, we need to free our resources to be able to handle our requests, and we don't want to pay for your idle time because you are not paying for your idle time as well. So we need to have a smart mechanism of actually pooling and managing resources. So the invoker is also the thing where the magic happens, you know, that transparent scalability, automatically scaling. We can have as many of those as we want. Of course, the other components scale as well, but the invoker is the thing that needs to scale to, well, theoretically infinity. So this is how the open source version of OpenWhisk looks like. We also have a deployment of it in Bluemix, so let's have a look at that. Exactly the same, right? So yeah, we are open source. We use exactly what we put out in the open. One, because we are open source, and two, I do not want to manage two different code bases, so why use something different? We use the same. But there are some tiny little bits that we make different. For instance, CouchDB. In IBM Bluemix, we have a service which is pretty good. It's called CloudEnd, which is essentially hosting a managed CouchDB instance. So we exchange that. Also, being deployed in Bluemix means we are integrated into Bluemix as well. So we have an integration service which is standing in between Bluemix and us and doing all the heavy lifting. But as we are essentially integrating with something that is open as well, Bluemix is entirely built upon open systems. Why do we need to close that service? Well, the answer is we don't. So due to priorities, we haven't yet come around to actually throw this one out into the open, but we will soon. So there's this little soon button on there saying, okay, this will be open source sooner or later. We also deploy some monitoring and log analysis stuff, which is mainly used for us ourselves to actually operate the system well. So these are ELK, so Elasticsearch, Logstash, and Kibana Stack, and a little bit of monitoring. There's no reason not to open source those, no secret source in there. So we will open source those as well at some point. So I promised we will talk a little bit more about Docker. Docker is probably the hugest giant that we stand on. Pretty good thing. And what do we use Docker for? Well, we use Docker to isolate the actions. You can imagine an invoker is running basically on a VM. Yes, we are using servers, but we're building a serverless system. So yeah, the actions are running on one VM, and potentially there are many actions of the same user running on one VM. So what we need to do is we need to isolate those, right? I don't want one user to interfere with the actions of another, or even see what other users are doing in our system. That would be leaking personal information. Very bad thing to do. So in theory, a native implementation of serverless might be, okay, you want to invoke that action, we Docker run the container, start the container, run the action, throw the container away. So does Whisk action invoke actually equal Docker run? Well, kinda. Let's have a look into how we actually run containers on the virtual machine that the invokers are running on. So really, the first thing that we need to do is we need to launch the container, which is a Docker run. And in OpenWhisk, Docker run means we start up the runtime. So for example, we start up a Node.js, we start up a Swift runtime or a JVM, you name it, depending, of course, on what you've sent, of what you sent us. Second, we need to initialize the Docker container with the code that you provided. So for instance, you provided a Node.js action, we inject the source code of that Node.js action into the container. Well, that's not much to do, right? But imagine a language like Swift. Swift we need to compile, and the compilation actually happens on that initialize step. So depending on the language, there might be quite some overhead in that initialize step. And the third thing is we run your action. No-brainer, right? Okay, so if we need to do all these 3 steps, we are talking of a code container. So it's freezing code, it's moving very, very slowly, a lot of overhead to do. Well, we need to go faster, right? So what do we do to actually get this faster? Well, we reduce overhead. So we just get rid of it. We get rid of Docker run. As said before, Docker run for us is starting up the different runtimes that we support in OpenWhisk. So we can do that beforehand, right? The invoker keeps a pool of, say, 5 Node.js engines, 2 Swift engines, because we notice there's more Node.js usage than Swift usage, and so on and so on. And we call those pre-warmed containers. So they are not yet initialized, they're not yet ready to run your code, but at least the container is there. So the network is set up, the engine is started up, and so on and so on. So we reduced the overhead of the actual call. So it gets a little bit warmer on there. So as said, init can mean a lot of overhead as well. Compiling a Swift action is not exactly something that you do in 5 milliseconds. So let's get rid of it as well. So now we have warm, burning containers ready to actually execute your code. And warm containers are also referred to in serverless speech with container reuse. So what does that mean? Well, that means we're not getting rid of the containers after we've run your action immediately. Say you run the same action twice. Well, the invoker could just say, okay, I have the same invocation twice. Say I have a second of time between them. Why not run them in the same container? Well, that's just what we do. We keep the container alive, make sure that you're not consuming resources though, but we keep it alive and rerun the action again. And now we're actually in a field where an action invocation can get really, 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 really fast. So that's how we optimize the usage of Docker containers in our on our invoker VMs. I've just scratched the surface on how OpenWhisk is working underneath the covers, right? So there's a lot more to talk about. Unfortunately, we don't have too much time today to do all this, but I would like to encourage you to either hit me up after the talk, ask me whatever you want to know. I will be glad to answer your questions. Or even better, meet me on github.com and ask questions as issues, or even better, open a pull request. And there's a, like, say, 99% chance that I will be reviewing your pull request. So feel free to reach out, please. Back to Andreas.
Yep. Yeah, and of course, ask him in Japanese just to make the challenge a little bit more interesting for him. So Markus has now dived into how we build OpenWhisk. But one question that remains is, what the heck can you build with it? It's not a special purpose technology. It's a general purpose technology. So there's an unlimited set of scenarios that you can build. So if you have listened to Olivier's talk, he has shown you already some very interesting and compelling scenarios. And in the interest of time, I do not want to go through all the potential things that you can build. But of course, let me give you one or two examples. So maybe you are a mobile developer, and maybe you are developing an iOS application, and then you realize, well, there are some things that are really compute intensive, and I do not want to run them on my mobile device. Let me outsource that to a scalable cloud platform. And as I've already said, we try to make that for you very easy, because you can implement these little actions in the same language that you already used when you implemented your iOS application on the client side. Even better, we provide you with SDKs to make it even more convenient. So we have iOS SDKs. Maybe you want to do something totally different. Maybe you want to build microservice-based apps. So maybe you want to build a web application or a mobile application, and if some buttons are being clicked, then the code is supposed to be run on the server side, just because maybe, again, it's calculation intensive, or maybe you want to use a Bluemix service very good in doing that, so you can outsource a lot of stuff on the server side. Maybe you want to build an IoT solution where you have an IoT service that is supposed to kick off some action on the server side just because some data has been sensed. So there's a lot of potential scenarios behind all that. I would like to encourage you, we will be here the entire day, to just come to us and tell us about your ideas, your scenarios. We are very interested in working with you. We want to learn from you. You are developers. You are our target audience. Do not hesitate to talk to us, discuss, maybe even start a cooperation. We are even looking for customers that want to go on stage with us. So if you have a damn cool scenario, we will invite you maybe to Las Vegas in February to be on stage with us and do a very cool demo. You have to pay for the flight, but that's a detail. So coming to the programming model. So how does it really work, and how does it really feel programming serverless with OpenWhisk? So the services emit the events in the form of triggers. The only thing you as a developer have to do is you write these little actions I've mentioned so often already. And then you have to define the little rule, and the little rule associates the trigger with the action. That's all you need to do. Once again, you don't need to worry anymore about all the infrastructural and operational stuff, scalability, high availability, infrastructural security. Forget about all that. Resiliency, it's not your business anymore. You write your code. So the triggers are actually classes of events that can happen, and they can come from totally different services. This one we have already seen. So there might be a cloud service, and it might emit an event just because something has changed in the cloud service, and maybe you want to react to that. Maybe you have an analytical or cognitive service. So maybe you have scanned or are scanning a Twitter stream, and the analytical service detects, well, there's someone complaining about me. And just because of that, it's emitting an event to inform you that someone is complaining about you, and the action contains then code to inform your customer relationship management team that someone is complaining, and the customer relationship management team can then get in touch to fix the situation. Maybe you have an IoT scenario where sensors are emitting events that you also want to handle via an action that you have implemented. But there can also be totally different services. So maybe you want to react because something has changed in a GitHub repository. All these things are happening. It's an unlimited amount of scenarios you can implement. Yeah, and of course the actions, they are the code handlers, the event handlers that you can implement in the different languages. Just to foster reuse and to make it possible to change behavior quickly and reuse all the actions you or the other teams have already developed in the past, we also support higher level constructs. To just mention one, we support chaining and sequencing. So once you have developed the action A1, A2, and A3, you can define one action that is the concatenation of these three actions, and you can define a second action which is also the concatenation of these three actions, but in a different order. You could also build a new action that is the concatenation of these three actions plus a fourth one. So you can do a lot of reuse, and you can reuse all